Hello students. Today I am going to talk about graph of motion. Already you have learned about theory part of this lesson, graph of motion. In first part, displacement time graph. It's a graph of motion, displacement respect to time. Then already you know its gradient represent velocity. Gradient represent velocity. Gradient mean you can see here gradient equal to tan theta. Gradient equal to tan theta. Theta mean this angle. This angle or this angle. Both are same. They are corresponding angles. Also, you know, you can find gradient as you learn in grade 10. Y difference over X difference. Then same equation here. Same formula here. Y difference mean S2 minus S1 is represented as delta S. X difference mean T2 minus T1 is represented by delta T. Okay. Then you can write gradient S2 minus S1 over T2 minus T1 or delta S over delta T. All are same. These three types are same. Representing gradient. Gradient equal to velocity of body. Velocity. Especially keep in mind this displacement time graph. Okay. Also, this line represent uniform velocity. Okay, velocity mean uniform velocity. Next, let's learn about other type of displacement time graph. Here, shown below are successive option of a vertically projected ball. When photograph during its motion under gravity is equal period of time. Then you can see here, they have considered same period of time. Then if you consider same period of time, its displacement should be increased. Okay. What type of motion here? Acceleration. Gravitational acceleration. Okay. Free falling object. This is a free falling object in acceleration. Then here you can see the displacement will be increased. Okay. When free falling object. Okay, next. It's all things I have taught you, but I want to remind it. Here, displacement time graph. What's the difference of this? It's a curve. Okay, if you find a curve, how do you find the details of this graph? Then in previous case, you have learned gradient represent velocity. Then how do you find gradient from this graph? Then you can't find a straight line. But if you consider any point on this position, their velocity different from other point. Okay, they haven't same velocity. It is changing. Okay, velocity is changing. How do you find it? If you want to find the velocity in this position, you have to draw tangential. You have to draw tangential here and find the gradient of that tangential. Okay, like this. You can draw tangential relevant point. Then here you can see this explanation. Then you can see here, then they have found velocity of this point. Then what should you do? Tangential making and find its gradient. Delta x here. Delta x mean delta x. It's much better if you write delta s. They have other symbol here, delta y. Don't worry about it. You can consider any letter for it. Delta x, delta y, delta s, delta h. Okay, a letter. But normally time represented by t is delta t. Okay. What about this gradient? Then you can see here this angle will be decreased. Okay. When you go in to upward, this angle is decreasing. Okay. If you consider this point, gradient, its angle is smaller than previous case. Then gradient is decreasing. Then what about velocity? Velocity also decreasing. Then this curve represent deceleration. This curve represent deceleration. What about other part? If you draw tangential, you can see their gradient. If you draw tangential, you can see the gradient is increasing. Here gradient, this angle, here this angle. This angle is increasing. Then when angle is increased, the velocity, acceleration or velocity should be increased. When velocity is increased, it is an acceleration. Okay? It's an acceleration. Then you can see this curve represent acceleration. Also, you can see here if you consider this part, the object moving away from the observation point. Moving away from observation point. Also, this graph represent object moving towards the observation point. Because of, if you consider this point, displacement is 0. Displacement increasing and decreasing away from observation point and towards to observation point. There are two parts. Also, here, if you talk about acceleration and deceleration, this part represent deceleration. Also, this part represent acceleration. Okay, you can consider using this inclination or gradient. Okay, then gradient represent velocity. Same case. Here you can see it's also a displacement time graph. Always keep in mind, look at this point, okay, clearly, because of sometime it may be displacement time graph or velocity time graph, even acceleration time graph, okay. I think pay attention for that y-axis. This same case here. Then if you find the velocity, if you want to find velocity in this point, you have to draw a tangential and find the gradient of this tangential. Okay, complete right angle triangle, and you have to divide this opposite side. If you consider this angle, respect to this angle, you have to divide opposite side by adjacent side. Okay, it's a gradient. Then here you can see a gradient, this angle is increasing. Then what happened? When angle is increasing, the gradient should be increasing. Also velocity is increasing. Mean it's an acceleration. Okay, this part represent acceleration. But like not previous case, this is this object moving away from observation point. Also acceleration. In previous case, away from observation point, but deceleration. It was like this graph. Okay, its inclination is decreasing. Inclination is decreasing. Okay, this angle, if you consider this like this angle is decreasing. But this graph represent away from observation point, but it is acceleration because of this angle is increasing. It's not difficult. Next, okay, now you know about the displacement time graph clearly. I'm reviewing this because of already you have learned this in your physics class from me. And next, velocity time graph. Then how do you find velocity time graph? You can see here in y-axis represent velocity, okay? But x-axis normally represent time. Then what is represented in this graph? It is uniform velocity. Uniform velocity. Okay. If it is parallel to x-axis, it represent uniform velocity. Then here we can consider about gradient of this graph. Like previous case, in a velocity time graph, we have seen its gradient represent velocity. Okay. Rate of change of displacement equal to velocity. Then in this case, represent rate of change of velocity. Velocity time graph, gradient represent rate of change of velocity. Then rate, rate of change of velocity equal to gradient. Then gradient of velocity time graph represent acceleration. Okay, acceleration. Also, it's a uniform acceleration because of it's a straight line. But in this time, you have to learn a special case about here deceleration. before going to that special case, let's focus our attention about deceleration. If it is deceleration, the gradient should be negative. Okay, this angle is obtuse angle. Okay, also its velocity is decreasing. Don't worry about it. You can use same method to find deceleration. Okay, you can if you consider this large triangle or this small triangle, you have to gradient. Then you can find tan value of this angle. Okay, these all angles are same. Then because of they are corresponding angles, then you can find, if you consider this large triangle, you can divide this height opposite side by adjacent side. Opposite side by adjacent side. But its sign should be negative because of it make obtuse angle from positive direction of x-axis. Then their gradient should be negative. Also, it has a negative acceleration. Negative acceleration known as deceleration. Negative acceleration known as deceleration. Other name is negative acceleration. Then their special name is deceleration. Okay. Then if you call deceleration, don't write a negative sign. Then it is different from displacement time graph. In this time, we are talking about area of velocity time graph. This area. What represent by this area? It represent displacement. Area between graph and time axis represent displacement. Okay, represent displacement. This this rectangle, you can find it length into breadth. Then it's equal to displacement. A simple case. But it's not always a rectangle. It may be different shapes. Maybe triangle like this. You can find area of a triangle using half into base into height. Sometimes you can find parallelogram, parallel trapezium. Then you can find it directly or separating each parts. Actually, already you have learned about these simple cases from your grade 10 class. Then, but in this year, you have to learn some complex things. Then consider the work example. Consider following displacement time graph. Explain the motion of the body in each of the following sections. If you consider, okay, you have to recognize this each parts. O to A. What about this graph? Then where should be focus your attention at first? You must attention about this sign. It is, you can see here, S. Then this is displacement time graph according to description. Let's check the shapes of these graphs. Okay, recognize properties of that motion. Then O to A. You can see here a straight line. Then it should be uniform velocity. Okay. uniform velocity, but may away from observation point because of displacement is increasing. Also, you can see here may answer, but keep in mind it is away from observation point. Observation point means starting point. Also here you can see here away from observation point also gradient is decreasing. Inclination is decreasing. Then what type of motion here? It is a deceleration. It's a deceleration. Okay. Also here you can see horizontal line is not a change in displacement. If it is not change in displacement, then it should be stop or rest. Okay. It is rest. And next case, you can see here, their gradient is increasing. Then, what type of motion? It is an acceleration. Acceleration also, it is moving towards the observation point or starting point because of it is decreasing displacement. Okay, it is decreasing displacement. In previous case, you can see it is also moving to observation point. Also, it is this inclination is decreasing. Inclination is decreasing or gradient is decreasing. Then it should be deceleration. Then here in last case, last duration, it is also rest. Okay. Also in this case, you can see it is not coming to starting point. Okay. If it is across the time axis, reach to time axis, it is coming back to initial point. But in this case, not coming to initial point. Okay, here you can check your answer. Then next one, consider the motion represented by following velocity time graph. Here velocity time graph. Okay. Don't mix velocity time graph and displacement time graph. Okay. Focus your attention to this y-axis. It is velocity time graph. If it is a velocity time graph, this part represent acceleration. Acceleration. Okay. So AB represented by AB. It is uniform velocity. BC, deceleration. The BC represent, tell me, BC represent coming back or not. You can may tell it is because of this motion up to time axis, motion represent into one direction. Okay. Then it is going to away from observation point or towards maybe towards observation point, or exactly we can tell it is moving into one direction in upside of time axis. But in this graph, you can see there is a part in downward. It is represent opposite motion. Okay, opposite motion. Then here acceleration, here uniform speed, here deceleration, and you know this point represent a zero velocity. Zero velocity means stop. After that, it is moving. This graph represent acceleration. Acceleration, but opposite side. Change in their direction. Okay, change in their direction. Also, pay your attention to this case. Then you can see here this inclination. This inclination is same. Okay, inclination is same. It means this deceleration, this magnitude of deceleration equal to magnitude of acceleration. If this is 10, this is also 10. Values are same because of that gradients are same. Inclinations are same. If you consider DE, it is represent deceleration. Finally, it is stopped. Okay. You have to describe there also. You can check these answers. Already we have talk about these cases in third question. Rubber ball threw vertically upward under gravity with velocity 40 ms-1 when returned to level of projection. It collides with a horizontal surface and rebounds with the velocity half of the velocity of collision. Draw the displacement time graph and velocity time graph to express the motion described above. Second question, determine time between the starting moment and the first collision. Determine the maximum height that by the ball reach. First, you have to draw displacement time graph and velocity time graph. This you can check this answer. Then let me focus my attention into displacement time graph. Here you can see here it's project vertically. Then it is project vertically and coming back and rebounds again. Okay, and then you know it's not going to initial point. Then the highest point, that highest point should be decreased. Okay, because of it lost energy. Then that practically, you know, if you throw a ball vertically, it rebounds several times, but the maximum height should be decreased and finally stopped. Then this graph represents it, but don't misunderstand. It is not moving like this. It is not moving to straight line. Okay, it's not a straight line here. Moving path. This is not a path. It is only represent time. Okay, but object moving vertically like this. Okay, it may be vertically or it may be like this. Okay, because of we have considered only vertical part. Okay, vertical motion here. But if you can't decide it is vertically motion or with horizontal motion, you can't check it using this graph. Okay, if it is like this motion, graph is like this, if it is like this motion, vertical, graph is same. Don't worry about it. May no need like that may things for this question. I talk about additional thing. What about this shape? It is represent, already you know, if you project something vertically, the velocity is vertically, velocity is decrease. Velocity decrease. Then it represent a deceleration. Then this graph represent deceleration. Also this part represent acceleration. It is coming back. Also next time, the maximum height is decreasing. You can see here, maximum height decreasing. Okay. Then next you have to draw a displacement time graph. If you throw object vertically, its velocity is decreasing. Velocity decreasing means a deceleration. And here, stop point. You know, in highest point, it should be stopped. Okay. After that, coming back, okay, into opposite side. Also, you know, it is it's an acceleration. Then here you can see acceleration here. Also, this inclination is same. Because of this acceleration is 10, also deceleration is 10, it's negative 10. If you consider acceleration, it's negative 10. If you tell deceleration, not tell sign, deceleration is 10. Also here, acceleration also 10. Because of, we know, gravitational acceleration is 10. Or if you tell it exactly, it is 9.8. But we take approximate value as 10. After that, here you can see that difference bounces. Okay, here you can see it's represent. How do you find bounce in height, move in height? In first case, move in height represent this area. Also, it's equal to this area because of if it is moving 2 meter into upward, coming back 2 meter. Okay, when it is touch the ground. In next case also, this triangle represent moving to upward, then this triangle represent moving to downward. This area should be equal. Also, these gradients are equal. Then 10. Then you can see this, it's a special case. These lines are parallel because of gravitational acceleration not be changed. Okay, it is a constant. Gravitational acceleration is 10. This then this inclination should be same. It is parallel lines. Okay, you can check this answers. Also, you can calculate this gradients. Like previous case, gradient, you can find the gradient from that triangles. y difference over x difference, or velocity difference over time difference. Okay. Also, area represent displacement. Okay. If you want to find first bounce height, you can find this area. Okay. The area mean half into base into height. Half into base mean 4. Height mean 40. Okay. Also, you can find this area using this couple of details. Okay. Also here. Gradient can find dividing this opposite side by adjacent side. It's not difficult. Also, next, you have to learn about GC A-level past paper question 2024. The graph of the variation of velocity with time of an object is shown in the figure. The corresponding displacement time curve is best represented by. The velocity time graph is given. Here, velocity time graph is given. You have to find that suitable displacement time graph. You have to find suitable displacement time graph. Okay. Then you must consider these time periods. Here you can see here 4 periods. Separate to 4 period. Also here you can see separate into 4 periods. Okay. Then you must compare each periods. Okay, each time periods. In first period, first period represent this velocity time graph. This line represent acceleration. Okay, acceleration. Also, we know this part represent into one direction. This, if it is in negative side of velocity, it represent motion of opposite direction. Okay, velocity. Then then if you consider first period, it should be acceleration. Then here, the inclination, you can see inclination is increasing. This is correct. Okay, this one. This acceleration is this not accelerate, it is deceleration because of inclination is decreasing. This we can reject this. Also here acceleration is okay. Okay. Here deceleration, we can reject this. This also acceleration, it is correct. Okay. Then next you can see here horizontal line. Horizontal line represent uniform velocity. Uniform velocity, what should be the shape in displacement time graph? It should be a straight line. A straight line, angled, a straight line. Okay, here you can see a straight line, angled, a straight line. It's okay. First one, correct. Here also correct, straight line. Then first case second among consider kare second correct make second correct. If you consider this, it is also a straight line. It's also correct. Okay. Next part, it is a deceleration. Okay, deceleration. Deceleration means that inclination should be decrease. Gradient should be decrease. In this case, you can see deceleration is its gradient is decreasing. Inclination is decreasing. Okay, then this is correct. It's matched with velocity time graph. Now we are consider this this time duration. You can see here it is also deceleration. Deceleration. But can you think about this time? This time, we can't accept this because of it is coming back. Here you can see displacement is decreasing. But in this graph, not represent opposite motion. When it is opposite motion, graph should be downward the time axis. Okay, then we can reject this. Okay, we can reject this graph because of it represent the opposite motion. Because of this displacement is decreasing. Can you understand it? Look at clearly. We are considering this third time period. Then it is coming back because of displacement is decreasing. Okay, displacement decreasing. But this part not represent opposite motion. Okay, it is moving same direction. Okay, accelerate, uniform speed, decelerate, and here stop. Not coming back. Okay, but this graph represent coming back. This we can reject this. Okay, now remaining only two graph. This couple of graph. Okay, we didn't consider this third part. Let's check it. It is also represent deceleration. Okay, third period. Until third period, both graphs are equal. Okay, equal. Let's consider last period. Last period. It is turning. Okay, it is moving opposite side. Moving opposite side. Then displacement should be decreased. Here you can see displacement is it's also acceleration and moving to opposite. Here you can see acceleration moving to opposite because of displacement is decreasing, coming back. Here also acceleration also coming back. But in this graph represent coming back to initial point or observation point. Coming back to observation point. If it is coming back to observation point, this area should be equal to this area. It can be happen. It can't be happen. Okay. Then this graph should be rejected. Okay. Then answer is third one. This is the correct answer. And 2022. Okay. Then if I explain it, I have to take a lot of time, but in the exam, you must do it in 2 minutes. Okay. Only 2 minutes you must analyze fast and decide it. Okay. But I have to explain it step by step. 2022. The displacement time graph for the motion of object is shown in the figure. The corresponding velocity time graph would be best represented by. Here it is given graph is displacement time graph. You have to find suitable velocity time graph. You have to find suitable velocity time graph. In first case, you can see here first time, you can separate this graph into 3 cases like this. Then you can see first period, it is deceleration. Okay, inclination is decreasing, gradient is decreasing, it is deceleration. Okay, also it is moving away, not coming back, not coming back. Then in this time period represent horizontal line, it is representing rest, it is stop time. And after that, it is acceleration because of inclination is increasing. Okay, and here deceleration, rest, acceleration. Okay, then here represent uniform velocity. We can't reject this. Here acceleration, but in first case represent deceleration. Then we can reject this. In third case, here deceleration, it is okay, deceleration stopped. Here also stopped. Next, acceleration. This part represent acceleration. Is third graph okay? Okay, let's check other graph also. Third is okay. Most suitable, you have to find most suitable. The other graphs are wrong. Okay, fourth one represent acceleration, uniform velocity, and deceleration. And fifth one represent deceleration, stop, and change the direction. Okay. Then sometime you will be confused with third and fifth. With third and fifth. Because of then first part and second parts are same. Okay, same, but third part is difference. This part represent acceleration. This is also this is deceleration, but into opposite direction. Okay, opposite direction. But in displacement time graph not represent opposite motion. Okay, it is moving into same direction. 2020, the figure shown, the figure shows the velocity time graph for an object moving along the straight line. What is the average velocity of the object from t equals 0 to t equals 4 seconds? Now you have to find average velocity. Average velocity from in this time, in this 4 seconds. Okay. Don't confuse about this. It is a simple question. Then you have to, if you want to find average velocity, first find the whole displacement, and next find the whole time, whole moving displacement, or motion of displacement and motion of time. Then after that, you can may find it dividing displacement by time. Velocity equal to displacement over time. Then let's consider until 3 seconds. Time is 3 seconds. May also you know about time. May not any problem. Time is 4 seconds. Challenge is you have to find whole displacement. How do you find whole displacement? You have to find areas. This whole area. Then what is the area of this large figure? It's square 3 into 3, 9. Displacement is 9. If you consider this small one, it's also a square. Don't consider these shapes. Okay, always attention to that values. Here, velocity is 1. Also, time duration is 1. This area is 1. Then whole area is 9 plus 1, 10. Area represent displacement. 10. Time is 4. 10 over 4. Okay. 10 over 4 means 2.5. Answer is third one. ms minus 1. 2.5 ms minus 1. (2020) other question. Parachutist bails out from the helicopter at t equals 0. After a certain time, he opened his parachute and then reached the ground. Which of the following graph best represent the variation of vertical component of velocity of parachute with time? Then, as I told, parachute man may be moving into this direction, like this. Okay, but we consider his vertical motion. Okay, we consider only vertical motion. Okay, then here you can see here vertical component. Okay, vertical component means he shouldn't be move on a straight line. Okay, it may be it should be move on a angled line. Okay, but in this case we consider only vertical component. Okay, vertical component. Because of he has two components, vertical component as well as horizontal component. If you move in this line, you have couple of motion. One is vertical, other is horizontal. Okay, there are couple of motion. In this case, we consider only vertical motion. Then, if we consider first time before open his parachute, what should be the motion? It should be acceleration. If we jump out of the helicopter, its motion should be acceleration. Okay, acceleration. Then here, what type of motion here? It's a deceleration because of inclination is decreasing, gradient is decreasing. then we can reject this. In this case, it is uniform. Also, sorry, then in this case, it is little confused, okay? Because of when it is velocity time graph, it should be deceleration. But in this case, you haven't learned this type of graph in velocity time graph, okay? You have learned like this graph in displacement time graph, not you haven't learned this type of graph in velocity time graph session. Then you can reject this graph, okay? Here you can see here a straight line. It is acceleration, okay? Uniform acceleration. Then we know it should be 10. 10. Then we can consider this as correct. But also we can reject this. It's a curve. Curve 1 in velocity time graph. It is little confused, okay? Also, we can reject this. Also, this all one can be reject because of their curved graphs. Then we can accept this second answer. Okay, second answer can be accepted. Also, you can see here after open parachute, their acceleration should be smaller than previous one. Here you can see, and this time we can't accept this graph also because of here you can see inclination is this represent this angle. Here inclination is greater than previous one, but it is a deceleration. Okay, it's okay. Okay. If you open the parachute, velocity should be decreased. Okay, and it stopped. Finally stopped. We can accept this one. But if you consider friction of air, okay, friction, air friction mean air resistance. If you consider graph may be different, but in your knowledge, with your knowledge, you can decide suitable graph is here. Okay. 2019, a figure shows a displacement time graph for a motion of two cars with respect to lamp post side road. It's a displacement time graph. Consider the displacement to the right side of lamp post as positive. Right side is positive. Left side should be negative. Okay, if you consider one observation point, if you consider velocity, if this direction is positive velocity, no need observation point. You can consider only direction. If right side is positive, other side should be negative. Okay. But if you consider displacement, you must consider observation point. From observation point, you must consider positive and negative. when right side is positive, if you pass observation point into opposite side, the displacement should be negative. Okay. But in velocity, if you consider velocity, don't consider about observation point. You can consider directly when right side is positive velocity, other side, opposite side should be negative velocity. Okay. Then let me read this. A student has made the following statement regarding the motion of cars relevant to the point P, Q, and R marked on the graph. A student has made the following statement regarding to motion of cars relevant to point P, Q, and R marked on the graph. A. Relevant to P. Car 1 coming from left crosses car 2. B. Relevant to Q. Both cars are moving towards the lamp post and cross each other. C. Relevant to R. Car 2 coming from right passes the lamp post. If you consider this couple of graphs represent two cars, this first graph represent car 1, then second graph represent car 2. Okay. Then if you consider first car, it is moving into right side. Consider displacement to right side lamp post as positive. Okay. Then P, what about P? This part represent uniform velocity. Uniform velocity, and moving to that lamp post, towards the lamp post. Okay, because of they measure displacement from lamp post. When it is displacement is 0, we can consider he is near the lamp post. Okay. Then here you can see displacement is 0. Then displacement is 0. Then he is on lamp post. After that, the car 1 is moving away from the lamp post in uniform velocity. Uniform velocity. Then P. First one was relevant to P ගත්තොත් car 1 coming from left cross the car 2. Cross the car 2. Then we can cross car 2 කියලා කියන්න පුළුවන් දෙත. Here is point. We can tell he is near the lamp post. Okay, here. Then we can't tell about in this time. What about car 2? It is, then we consider this time. Car is in right side. Okay, right side, we can consider any displacement here, but car 1 is in near the lamp post. Okay, but car 2 is away from lamp post. Away from lamp post. It is coming left. It is correct. Then car 1 is coming to left. Cross the car 2. But we can't tell cross the car 2 because of car 2 is away from lamp post. Okay. And B, if you consider B, relevant Q. If you consider Q, what about it? Displacements are equal. Okay. Both displacements are equal. This may be that cross point. Okay. Relevant Q, both cars are moving towards the lamp post and cross each other. Across each other, it is okay. Please cross each other. But in this time, both cars are moving towards the lamp post. Towards lamp post mean, is it correct? This car 2 is moving towards the lamp post because of it is decreasing displacement. Okay. But car 1 is increasing displacement. Then it is moving away from lamp post. Okay. But they are crossing. It is okay because of displacements are equal. C, relevant to C, relevant to R in this time. Car 2 coming from right passes the lamp post. It is okay. In this time, car 2 coming to near to lamp post. Okay. It is coming from right passes the lamp post. It is okay. Then correct one is only C. Correct one is only C. Uh, 2016 question. The two straight lines shown in the displacement time graph represent the motion of two objects A and B started from rest t equals 0 and moving along the positive x direction. Which of the following statement made about motion of the object is true? Then here you can see here is given displacement time graph. Then don't depend on this symbol. You can see here, you can't see here S. They have given displacement D for displacement. Okay. Then don't depend on that symbols. Okay. It may be S, D, or Y, X, any symbol. Okay. We want to get idea what is represented by that symbol, relevant symbol. This displacement time graph. The motion about A and B, two objects. Moving along positive x direction, which following statement about motion, the object is true. First one, the object A has traveled from a long time than B. The object A has traveled for a long time than B. It is wrong. This time both have T naught. When T equal T naught, object B has made the displacement greater than A. It's also wrong. Right? Then B displacement here and A displacement is greater than B. It's also wrong. Third one, object A has greater velocity than B. Object A has greater velocity than B. Then velocity represented by gradient. Then you can check the gradient. Here you can draw a horizontal line. Then velocity of B represented by this angle. This tan value of this angle. Also, velocity of A represented by this angle, tan value. Then we can see this angle is larger than B. Then velocity of A is greater than B. Then in this case, object A has a greater velocity than B. It is correct. Okay. Then you don't worry about other answers. If you find correct answer, you can correct it. If you want, you can read other one. They are talking about great acceleration. Then we can't find here acceleration. If it has acceleration, that graph should be curved. Okay. Deceleration, acceleration, graph should be curved when it is acceleration like this. Okay. Deceleration like this. Inclination should be increase or decrease. Increase, the inclination increase. It is acceleration. When gradient is decreased, motion should be deceleration. Here they are in the last case, both objects have same velocity at the point where two straight lines cross each other. In this point can be decide their velocities are equal. No, but one thing you can tell, their displacements are equal. Their displacements are equal. That crossing point. Okay. If you want, we can tell A and B meet in this point, in this displacement. Okay. But we can't tell about velocity. Velocity depend on gradient of the graph. Seventh one, a position of three motor cars, 1, 2, and 3, traveling along three parallel straight line of a road at time t equals 0 and t equal t naught, are shown in figure A. Their corresponding velocity time graph are shown in figure. The situation shown in figure A could have happened only if the area in the graph satisfy the conditions. Let's consider this seventh question. In this case, some student may be confused with this question, but you have to find a simple path to solve this question. Then, according to this figure, these three cars starting from the same time, same position, same time, also same position. Also, they are ending motion from a same position as well as same time. Then their moving displacements should be equal. Displacement should be equal. But according to this graph, then first car is accelerating. Also, second car is decelerating. Okay, decelerating. Third car, also it is decelerating, but greater than 2. Then what should be happen? What should be happen for this through this condition, through these conditions? What's the main condition? Their displacement should be equal. Their displacement should be equal. Then focus your attention to type of graph. It is a velocity time graph. How do you find the displacement from velocity time graph? How do you find the displacement from a velocity time graph? Already you know that area. If you consider velocity time graph, area between graph and time axis represent displacement. If you consider it may be a different shape of graphs. Then like this other side, it's also same. This area represent displacement. Area represent displacement. Then if these displacements are equal, this graph area should be equal. What's the area of what's the area represented by first motion, first car's motion? This area is this one. Mean OCEG. OCEG trapezium. OCEG trapezium represent displacement of car 1, first car. Displacement of first car. Then what about second car? Second car. If you consider second car, its displacement represent OBFG area. Okay, this trapezium area represent displacement of second car. What about displacement of third car? Displacement of third car represent area of this triangle. OAG. OAG triangle. Okay. I consider this point as O. It is 0, but I take it to represent these figures. Okay. Area of this figure. Then that figure should be equal. Area should be equal. Okay. Then when that areas are equal, what answers satisfy your answer? Okay. What's answer satisfy that conditions? You have to consider these answers. Look at clearly. Let's consider, first of all, let's consider motion of first car. Motion of first car mean this parallelogram, this trapezium. I will consider this trapezium. Okay. Second car may represent this trapezium. Okay. I will draw may outside to see clearly. Then when this first and second car is moving same direction, same displacement, their area should be equal. When these areas are drawn by red color and green color, then keep in focus your attention when this triangle area equal to this area. This triangle's area, then that couple of trapezium's area should be equal. There are additional parts. This is the common part here, common part. The additional part I have marked. Okay, then additional part should be equal. When additional parts are equal, then that trapezium's area should be equal. Then look at a BCD should be equal to DEF. BCD should be equal to DEF. Find that answer BCD equal to DEF. Here you can see here. Okay. BCD equal to DEF. It is here. We have to check other part. We have to check other part. Then also if this area mean ABD equal to DFG. If ABD area equal to DFG, then motion of displacement of third car should be equal to displacement of second car. Is it correct? Check it clearly. If ABD area equal to DFG area, then AOG triangle's area should be equal to OBFG trapezium's area. Then their displacement should be equal. Then answer is this one. Then second answer is correct. Okay. Then these are MCQ. Okay. Then you can think how difficult to manage your time. Okay. If you analyze this in half an hour, 30 minutes is not suitable for your A-level exam. You have to analyze this in 2 minutes. Okay.